In this video, I'll be doing two examples of differentiating through the product rule. In the first example, I have y is equal to x to the 7 times square root of 4x plus 7. And to differentiate this through the product rule, you know that we apply the product rule when we have two functions that are getting multiplied by each other. And then the derivative looks like this. And if we name our functions f of x and g of x as u and v, then the derivative would look like this. So here first I'm going to identify the functions u and v. I'm going to name this function as u and this function as v. Next I'm going to differentiate both of these functions. U is x to the 7, and so if I differentiate this, du upon dx would be equal to 7x to the 6. Next, the function v is square root of 4x plus 7. For square root, we also write this as whole power 1 upon 2. So I can write this as 4x plus 7 whole power 1 upon 2. To differentiate this 4x plus 7 whole power 1 upon 2, I'll need to apply the chain rule here. And according to the chain rule, first of all, the power comes down. So the derivative of v dv upon dx, which we also call as v dash, is going to be equal to, the power comes down, so 1 upon 2 times the inside function as it is, so 4x plus 7, and the power gets reduced by 1. 1 upon 2 minus 1 is minus 1 upon 2 times the derivative of the inside function. The inside function is this 4x plus 7, and its derivative is going to be 4. 4 divided by 2 is 2, and this power is negative. To convert this power into positive, I'm going to shift this term to the denominator. And so v dash is going to be equal to 2 divided by 4x plus 7 whole power positive 1 upon 2. So I found v dash and u dash, so now I can apply the formula of the product rule, which is dy upon dx is equal to uv prime plus v u prime. U is x to the 7, so dy upon dx is equal to x to the 7 times v dash, which is this. Plus v, which is 4x plus 7 whole power 1 upon 2, and u dash is 7x to the 6. So this is my derivative of this first function. I could either leave my answer like this, or I could simplify this further. To simplify this further, I'm going to multiply the brackets. So dy upon dx is going to be equal to 2 times x to the 7 is 2x to the 7 divided by 4x plus 7 whole power 1 upon 2 plus 7x to the 6 times 4x plus 7 whole power 1 upon 2. In order to add two fractions, the denominators must be the same. The denominator of this term is 1. So I'm going to make them same by cross multiplying, and I would get dy upon dx is equal to 2x to the 7 divided by 4x plus 7 whole power 1 upon 2, and then plus 7x to the 6 times 4x plus 7 whole power 1 upon 2 times 4x plus 7 whole power 1 upon 2, and then divided by 4x plus 7 whole power 1 upon 2. Now since the denominators of these two fractions are the same, I can add these two, and then dy upon dx would be equal to 2x to the 7 plus 7x to the 6, and these two terms, they have the same base, so the powers are going to get added. 1 upon 2 plus 1 upon 2 is 1, so 7x to the 6 times 4x plus 7. And in the denominator, I'll have 4x plus 7 whole power of 1 upon 2. 7x to the 6 times 4x is 28x to the 7. So dy upon dx is equal to 2x to the 7 plus 28x to the 7, and 7x to the 6 times 7 is 49x to the 6. and then divided by this denominator 4x plus 7 whole power 1 upon 2. 2x to the 7 plus 28x to the 7 is 30x to the 7. So my final answer is dy upon dx is equal to 30x to the 7 plus 49x to the 6 divided by 4x plus 7 whole power 1 upon 2. And since I cannot simplify this any further, this is my final answer. This is the derivative of the first function. In the second function, I have y is equal to x plus 1 to the 4 times 1 minus 2x whole cube. So here I am going to name this function as u and this function as v. Two functions are getting multiplied by each other, and so we use the product rule. But before using the formula of the product rule, I need to find u dash and v dash, that are the derivatives of these two functions. So u is x plus 1 to the 4. To differentiate this, I need to use the chain rule here. According to the chain rule, first the power comes down. So u dash, the derivative is going to be 4 times the inside function we write as it is, so x plus 1. The power gets reduced by 1, so it becomes 3, and times the derivative of the inside function, which is 1. This was u dash. Now for v dash, it is 1 minus 2x whole cube. This also is going to get differentiated by the chain rule. The power comes down, so v dash is going to be equal to 3 times 1 minus 2x. The power gets reduced by 1, so it becomes 2, and times the derivative of the inside function, which is minus 2 in this case. 3 times minus 2 is minus 6, so v dash is equal to minus 6 times 1 minus 2x whole squared. So after finding v dash and u dash, I can go on and use the formula of the product rule. The formula of the product rule is dy upon dx is equal to u v dash plus v u dash. Here u is x plus 1 to the 4, so dy upon dx is equal to x plus 1 to the 4 times v dash, which is this minus 6 times 1 minus 2x whole squared, plus v, which is 1 minus 2x whole cube, times u dash, which is 4 times x plus 1 whole cube. By removing the bigger brackets, I can rewrite this as dy upon dx is equal to minus 6 times x plus 1 to the 4 times 1 minus 2x whole squared plus 4 times 1 minus 2x whole cube times x plus 1 whole cube. So this is my derivative of this second function. I could either leave my answer like this, or I could simplify it further. To simplify this further, I can factor this out. I have 1 minus 2x in the first term and 1 minus 2x again in the second term. If I factor out 1 minus 2x whole squared, that is present in the first term and also in the second term, I am going to get dy upon dx is equal to 1 minus 2x whole squared. Now if I divide the first term by 1 minus 2x whole squared, I am going to get only minus 6 times x plus 1 to the 4. And then plus, if I divide this by 1 minus 2x whole squared, cube divided by square would leave me with the power of 1. So I'll get 4 times 1 minus 2x whole power of 1 times x plus 1 whole cube. In the bigger bracket, I have another factor again. I have x plus 1 in the first term and x plus 1 in the second term. In the first term, I have x plus 1 to the 4, and in the second term, I have x plus 1 whole cube. So I can factor out x plus 1 whole cube because it's present in the first term and also in the second term. So I would get dy upon dx is equal to 1 minus 2x whole squared times x plus 1 whole cube times minus 6. If I divide the first term by x plus 1 whole cube, I am going to get only x plus 1. So minus 6 times x plus 1 plus 4 times 1 minus 2x. Now in the bigger bracket, I can multiply the terms out. Minus 6 times x is going to be minus 6x. So dy upon dx is equal to 1 minus 2x whole squared times x plus 1 whole cube times minus 6x, and then minus 6 times minus 1 is minus 6, plus 4 times 1 is 4, and 4 times minus 2x is minus 8x. Minus 6x minus 8x is minus 14x, and minus 6 plus 4 is minus 2. And these two brackets as it is, x plus 1 whole cube and 1 minus 2x whole squared. And this is dy upon dx. This is my answer. This is my derivative of the second function.